You are welcome back to Engineer AGM Plus Academy. Today, we shall explore another interesting topic, and that is charge to mass ratio and atomic mass numbers. We shall discuss how to calculate the charge to mass ratio, their importance, and thereafter, we will calculate the atomic number and mass numbers. At the end of the lesson, you should be able to calculate the charge to mass ratio, and you have to know the application of charge to mass ratio. What does it entail? What does it mean? And finally, you should be able to calculate the atomic mass number of any atom or ions. There are three cases involved when calculating the atomic mass number of atoms or ions. All these cases shall be looked into. If you haven't watched Class 1, Lecture 1 and Lecture 2, to make this lecture understandable and interesting, I will advise you to go back to that module. Charge to mass ratio. Charge to mass ratio is simply the charge carried by a particle with respect to its mass. Mathematically, it is represented as Q over m. It is measured in coulomb per kilogram. What do we understand by charge to mass ratio? How does it apply to real life situation? First of all, we have to understand the fact that proton and neutron have the same mass, while electron is tiny. And again, we have to understand the fact that proton and electron both have the same charge. However, they go in different directions, which has been explained in the previous video. Now here is proton. Here is Mr. Proton, the giant rock. Let's find out its charge to mass. This is its profile, that is the charge is positive, that is 1.60 times 10 raised to the power minus 19, and its mass is given as 1.67 times 10 raised to the power minus 27 kilogram. How do we calculate the charge to mass ratio? Then it means Q over m. The ratio there can be substituted with a division sign. Q is 1.60 multiplied by 10 raised to the power minus 19 coulomb divided by 1.67 times 10 raised to the power minus 27 kilogram. Pick up your calculator and try this. What do you get? I believe you should get the same answer like this. That is 9.58 multiplied by 10 raised to the power 7 coulomb per kilogram. Approximately 95,800,000 coulomb per kilogram. Remember this value. Remember this. As for the small but mighty electron, let's view its profile. And here it is. Electron has a charge of 1.60 times 10 raised to the power minus 19 and a mass of 9.11 times 10 raised to the power minus 31 kilogram. How do we calculate its charge to mass? Its charge to mass ratio is given as Q over m. Then we substitute for the values of Q and m into this formula. That is 1.60 times 10 raised to the power minus 19 coulomb divided by 9.11 times 10 raised to the power minus 31 kilogram. Pick up your calculator and try this. I believe that should give you what? It should give you 1.76 times 10 raised to the power 11 coulomb per kilogram. And what does that mean? It means something close to 176 billion coulomb per kilogram. Now compare this value to that of protons. For proton, we have 95, close to 95 million, and proton has close to 176 billion. Still, do not forget this. It's not compulsory for you to cram or to memorize these values, no. In as much as you know the charge and you do know the mass, then you divide both and you get the value of the charge to mass ratio of these particles. Now what of Madam Neutron? Here she is. As for Madam Neutron, let's check our profile. We have a charge is 0. That is no electric charge, no charge at all. And a mass is 1.67 times 10 raised to power minus 27 kilogram. How do we calculate the charge to mass ratio? Almost the same thing. Charge to mass ratio is equal to Q over M, which is, then you substitute for the values and you have 0 coulomb per 1.60 times 10 raised to power minus 27 kilogram. And what does that give? 0. What does this really imply? Response of charged particles to what? To electrical and magnetic forces. In reality, the charge to mass ratios shows how fast an atomic subparticle reacts to electric and magnetic forces. For example, electron, proton, and neutron, comparing their charge to mass ratio, what does that mean? It means that electron has the highest charge to mass ratio, which suggests that it is the fastest to electric and magnetic force. Whereas proton, compared to electron, is slow, especially in electric and magnetic force. And neutron, no movement. And from that video, you can see when they were on the track, electron moves in the opposite direction, while proton goes to the other side. Fortunately for electron ran as fast as possible to reach the finish line before proton. So therefore, electron moves very fast compared to proton and neutron. In order for us to prove this, we use this equation, that is F is equal to QE, and that leads to mass times acceleration is equal to QE. Where do we get mass times acceleration? Remember that force is equal to mass times acceleration. Therefore, you substitute to get this. And when you divide both sides by m, you have A is equal to Q over m E. This Q over m determines the acceleration of the subparticle, and that is what this equation means. That is to say, if you substitute the value, the charge to mass ratio of electron into this equation, compare it to that of proton, neutron has 0. Therefore, electron is the fastest, or electron is faster than proton in electric field. The same application is adopted when calculating the acceleration of these particles in a magnetic force. We apply F is equal to QVB. In the future, inshallah, I am going to explain how we do this. Application of charge to mass. Does this really make sense? Has charge to mass ratio been adopted by scientists to develop any particular thing? Yes, of course. In our photocopier, in Nigeria we say photocopy machine. In our photocopier, charge to mass ratio is very useful, important. Here we have the document, that is the real document. We have a slant mirror as located in this image here. We also have a convex mirror placed in between two mirrors, just like this. And we have the drum, diffuser, we have the toner, and we have tray where paper are kept. What really happens here? After a document is placed in the photocopier, that is a written document here, a mirror reflects the image of the document to a convex lens. We also have our flash lamps and charge erase lamp. When the image is placed in the photocopier, a bright light scans it. This image is formed on this mirror, and this mirror reflects the image of the document to a convex lens, which is this. The convex lens focuses and slightly magnifies the image. That it makes this image bigger. Then this image is then reflected on another mirror, which then directs the image onto the drum. Here we have the drum, right? Of course, yes, the drum initially was positively charged using a corona wire. Why the drum is positively charged? Remember, we use red for positively charged particles in this lecture. This uniform positive charge covers the entire drum surface. Then this, you can see the charge erase lamp. This light reflected here on the drum. It's the drum discharging those areas. Remember, we have the image formed, and the lights will discharge the point where the image is not formed. I will explain this in the next slide. Now the dark written areas retain a positive charge because this drum is already positively charged. Then it goes to the toner. Now the drum has a charge pattern that matches the document: positive where text is and neutral where the background is. Now let's go to tonal abstraction. The tonal is already negatively charged. This charge attracts the positive image from the drum until the tonal particles stick to the positively charged areas on the drum. Thereafter, it goes until a paper is picked from the tray. What do we need to concentrate at here? What happens to the toner? Q per m, that is the charge to mass ratio, is applied here in the toner. Remember that electron moves faster, and interestingly, there are some toner whose particles are positively charged. In that case, when the particles are positively charged, then the drum will be charged negatively. But when the tonal is negatively charged, then the drum would be a positive charged. So in that case, there are some companies who design their toner to be negatively charged, and some others design their toner to be positively charged. As a person who understands chemistry, what advice would you give to such company that design their toner to be negatively charged? And what advice would you give to a company whose design makes toner to be negatively charged? Applying charge to mass ratio. Remember, electron moves faster than proton. Due to the Q per m, due to the charge per mass of electron, it moves faster until it covers all the positively charged image made on the drum. And we have a fusor here. This fusor produces heat that makes the image stick to the paper we received here. And this tray, this is where we receive our printed image on the paper. Can you now see how important charge to mass is to the world? To make it clearer, this is the process involved in photocopier. Drum gets charged. You can see the drum on the screen. Light discharge the image. The light from the lens discharge the image. And the toner sticks to the charged particle. Since charged particles are attracted due to their opposite nature, that is, opposite charges attract while negative charge repel. Afterwards, the toner fuses to the paper to make a permanent written image on the paper, one after the other. Let's assume this is the drum. The drum is now charged by the corona wire. You can see this is the corona wire. What is the meaning of charging? It transfers protons to the drum until it becomes positively charged, full of red protons. Then we have our mirror that reflects the image from the screen of the photocopier to the drum. Here is the light that reflects on the drum to clear off or to discharge the positive charges in the empty space on the image. That is, all these areas, the positive charge you find there, these rays of light discharge everything here. Then we have the image, but the image that is transferred from the mirror here becomes positively charged. Afterwards, we have the toner that is negatively charged. Due to the Q per M, that is the charge per mass ratio, it transfers the electrons towards it for attraction until it becomes like this. You can see the image there. After that, the diffuser produces heat, which makes the image permanently stick to the paper that is picked from the tray. As I said earlier, not only heat, but pressure. Atomic number and mass number. What is atomic number? Atomic number is the number of protons contained in an atom in its neutral state, while mass number is the number of protons and neutrons contained in an atom. Protons and neutrons can only be found in the nucleus of an atom. Representation. Atomic number is represented by Z, while mass number is represented by letter A. Atomic number is always placed below the element, while mass number is placed up at the top of the element. Don't be confused. Atomic number is represented by Z, while mass number is represented by A, opposite. This is a neutral atom. And for case 2, we have atomic number of an element that is negatively charged. Most often than not, these elements are always non-melters. Remember, we have the atomic number written down and the mass number written up. Case 3, for a positively charged atom, we also have the mass number written up while the atomic number is written down. How do you find the atomic number and the mass number of these atoms in these cases? Neutral atom negatively charged, and positively charged. For case 1, here we have lithium, magnesium, and oxygen atom. What is the atomic number of lithium? In the periodic table, we normally find the atomic number by searching for the position of the elements in the periodic table. Hydrogen, helium, lithium is number 3. Therefore, its atomic number is 3. So, number of electrons is equal to number of protons for neutral atom. You know that before, right? Which means the atomic number now is not equal to number of protons or number of electrons. That is for neutral atom. Mass number is equal to number of protons plus neutrons. But since the protons is equal to the electrons, then we can literally say mass number is also equal to number of electrons plus neutrons. Now let's see lithium. You can see on the screen, we have what is the number of electrons we have for the lithium. We have 1, 2, 3. In that case, the atomic number is 3. What about the mass number? It is within, which is 1, 2, 3. That is the number of protons plus the neutron. Neutron has 1, 2, 3, 4. How do we determine the number of neutrons? There is no conventional way to directly calculate the number of neutrons, but most often than not, the number of protons are always given by the position of these elements in the periodic table, and that helps us to know the atomic number. We will be given a mass number in order for us to calculate the number of neutrons. So the mass number now is equal to 3 plus 4. This 3 is the number of electrons or the number of protons. Then 4 is the number of neutrons. And that gives 7. I believe that is simple, right? That's all. Another example for case 1. When we say neutral atom, what does that mean? Neutral atoms means that the number of protons you have is always equal to number of what? Electron. Because it means that, let's count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, right? We have 12 positive charges moving against 12 negative charges. 1, 2, 3, 4, that is 1 plus 8, 9, 10, 11, 12. That is, we have 12 positive charges moving against 12 negative charges. Remember, both electron and proton have the same charge. Each charge of a proton is 1.60 multiplied by 10 raised to the power minus 19, right? But positive. While each charge of an electron is 1.60 multiplied by 10 raised to the power minus what? Minus 19 as well. Which means they will cancel one another until we have only neutron. Whereas neutron has no charge. So they're all fine. No one is greater than the other. So it makes magnesium to be neutral. In that case, the configuration, we already have the configuration, that is the 282 k-element shell configuration. In that case, the number of the number of proton is 12. That is the atomic number. And the mass number is 24. When you add this neutron together with the proton. Now let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 and this is 12, makes 24. When it comes to neutral atom, that is case 2. When it comes to ions, what do we do? A very good example is oxygen. In the nucleus, oxygen has how many protons? For me to know that, I have to know the position of oxygen in the periodic table, and that is 2, 6, and that is 8, of course. Therefore, we shall have 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. Neutrons, I may not know the value, of course. And if the protons are 8, definitely the electrons should be 8 as well. Do you have 8 here? Yes. Okay, now, what is the atomic number of oxygen? It is definitely 8. And what is the mass number? Since I am not given the number of neutrons, I can't calculate the mass number in that case. Let's now assume that oxygen gains 2 electrons from an external source. In order for it to fuse its outermost shell, and it gives this. Now the number of electrons here becomes what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 electrons, right? And we have how many protons? Protons does not change. It remains the same, even if it receives or loses electrons. So now what happens? If the charge fight against one another, we have how many protons? 1, 2, 3, 4, 5, 6, 7, 8, right? So these 8 protons, positively charged, will be cancelled out, and thus it will cancel 8 of these electrons as well. Then we have 2 electrons left here. This means that this is negatively charged, having 2 extra electrons, and this is why we write it like this. Now the question now is, when oxygen releases electron, what is its atomic number and mass number? Let's just focus on the atomic number. The atomic number does not change. It remains the same. Why? Because the atomic number does not affect the state of the atom. It only affects the transfer of electron. So the atomic number of this case is the number of protons only. And what's the number of protons? 1, 2, 3, 4, 5, 6, 7, 8. The atomic number of oxygen is 8. While the mass number, if the neutron is 8, is 16. Now in case 3, what of lithium? It has 3 electrons. It's given that it has 4 neutrons. Since it has 3 electrons, it also has 3 protons. So what happens to it? You can see that the outermost shell, that is 1 electron, now gives out its electron, so that we have only 2 electrons at the outermost shell now. The proton and the neutron remain the same. Then if you cancel it out, if you cancel the charges out, it remains only 1 proton here. This is what we call positively charged. That is, all the electrons has been cancelled by the effect of the protons. So we have 1 more positive charge left. Therefore, this becomes positively charged. And we write it in this manner: Li plus 1 electron that is already out here. So therefore, we write it in this form. Li becomes Li plus, positively charged, after giving out an electron. So what is the atomic number of lithium? Since it has given out its electron, it remains the same. The atomic number of lithium remains to be 3. That is, it has 3 protons, and the mass number is the number of the protons and the neutrons, and that is 1, 2, 3, 4, 5, 6, 7. Do you understand? Can you solve this? Try out this. And that is the end of the lesson.